all of my attention. All right. How long should we wait for folks?
I mean, we're sort of we just had like a rush of people come in. I think we can get started, and orient people more, as they materialize. Yeah. So welcome everyone who's here so far. This is session 2 of our summer series on ggplot2, and data visualization more broadly. And if you're in session 1, great. If you weren't, also great. They're pretty modular, so you can hop in and out as it suits. And this is actually, we're really excited about this session because we've got Devin Bailey, who knows about sort of principles of data visualization implementation, data visualization, here to tell us about sort of how to make plots that are, what to consider in designing plots so that they're effective tools for communication. And this stuff is new material for a lot of us in CCT data science as well. It's really exciting to be able to learn all of this. And then I will take over later in the session to talk about sort of how to take these things and put them into practice in ggplot2 and R. So we're excited for this session. We think it's going to be a really great opportunity to learn some of the like bigger picture principles about how to approach communication about data using graphics. And have some tools for making that happen in your own graphs. With that, I guess, Devin, if you want to get us started.
Sure. Sounds good. Wow, this is like, it's been so long since I've been able to give a talk that actually has like my presenter notes on a separate window. This is so fun. Hi, everybody. I'm Devin Bailey, and I am a data and visualization consultant in this nifty little department called the Research Technologies Department. So I like to say I'm like the library, or we're like the library, in that we're department agnostic, and so we work with everybody, and we also host the supercomputers that are here. And so some of my work takes place on them, some of it doesn't actually require the supercomputers too, because by the time that you're doing data visualization, in theory, some of your data has been sort of compressed into these numbers that you care more about and other numbers you don't care about as much. So anyways, I'm here to talk about data visualization, effective choices and efficient choices for data visualization. So if you have questions at any point, also feel free to stop us. I think both of our, we were joking about this timing wise, our material may either be too short or too long, but the most important thing is that you engage if you are thinking about something. I think that's the most worthwhile thing to happen. So feel free to stop me at any time. So a little roadmap for today's session. I like having these plans, and so this is what we're going to cover. Why are we trying to visualize data in the first place? I feel like it's not a PowerPoint presentation if we don't ask one of these sort of useless rhetorical questions. Like, you're here, you have a reason why, but I'll give you some of why I think data and visualization go well together. We'll talk about cases where we want to visualize it, and maybe instead why numbers or statistical summaries might be more appropriate. I'll also include a couple of quotes from some of the faculty members who teach data viz here. And then we're going to move on. We're going to actually talk a little bit about best practices from some big thinkers in the field. And I'm going to be focusing on Edward Tufte, you may know of him, and other researchers, Tamara Munzner, and this guy's name is great, Jacques McKinley, and Jacques Bertin. So there's a bunch of people whose ideas are going to boil down to a couple of concrete things. They say a lot of more abstract stuff, and I'm not going to go as much into that. But some of the concrete stuff boils down to these words like expressive versus effective vids. So we'll have a section on that as well. And I think this is going to be the part that ties the best in with what Renata is going to go through later, because I'm going to use these words marks and channels, but these words literally translate directly into ggplot stuff like geom and aesthetic. And so I'll try to make that clear when I'm going through that part of the slides as well. But that's going to be the most sort of concrete, useful thing for later on. And then I'm going to go through a couple of other resources like this thing called the data to viz flowchart, because the wide world of visualization options it's huge. You know, you could even say it's wide. But how do we decide, what types of visualizations might fit with different types of data? Again, like this is a field where there are no hard and fast golden rules. You have to try a lot of different things. And so having a framework for being able to choose what to try first, maybe not only, is probably very helpful. And then I know it's sort of weird that I'm including this at the end of the presentation when I consider it to be the most important first thing to do. We're going to do a hand drawing exercise. So right now, before I get into the slides, see if you've got a pen and paper or something that you can draw with nearby, because we're going to be doodling a little bit. I think every visualization project could benefit from starting off with oh yes, thanks for showing you got the paper. It could benefit from having a hand drawing first, or you start trying to find weird options and cryptic programmatic ways to make a chart. And at the end, I'll come back after Renata's piece and I'll talk a little bit about storytelling. And we'll do an exercise where we'll make breakout rooms. Can we make breakout rooms? Is that a thing? Paper scarce on your desk. That's
Yeah, we
fine
can do
too.
breakout rooms.
Awesome. So I'll make or we'll make rooms for each one of these quote unquote stories, and people can go into the room that they want to be in for the duration of the activity. Just a quick heads up, the last time I ran this activity, it was for a health informatics group, and all of their data is really morbid. It's like, it's part of the field, but it's things that are kind of intense. So we're recycling that data. I just want to bring it up early so that y'all can like be prepared for things that relate to like alcoholism and morbidity. So anyways, maybe in the future we'll have happier data to work with for our demo. But that's the rough draft of what this presentation is going to include. I spent a while talking about that slide, so I'll move on. So we're visualizing data. Why? I know that everyone in the room probably has some tie back to life sciences, and temperature is a big component of all of your projects. So I wanted to bring up this data that's from a collected daily temperature and precipitation data set for US cities. And I put together all of these different solstice temperatures now that we're in June. So this does tell us something about the data, but it is leaving out other attributes such as how much warmer or cooler were years before this one. Or I mean, this is just a general average. So we lose some of the information when we're just using summary statistics. So instead, a chart like this can tell us things about the distribution of each of the three cities, like Flagstaff, Phoenix, and Tucson. And it goes very well with this quote from Carlos Scheidegger, who's no longer a professor here, but he taught for a long time. And I think he was in charge when I was taking these classes on campus. And he's got this quote that says, "The way in which data is presented drastically changes how we consume it." So I think that most of what I'm going to talk about today is all about choices that relate to consumption for your audiences of your visualizations. So let's talk about our first big thinker who's going to give us some of these ideas that we can cover. So Edward Tufte was a statistician from Yale. He was born a long time ago. He's still alive, but I don't think he's teaching anymore. But he's well known, and he has these several books. And I'm mostly going to be focusing on material from that first one there in the corner, the visual display of quantitative information. He has a lot of strong opinions. Many of them are valid, but not all of them. So I want you to keep that in the back of your mind as I go through some of this stuff. To highlight that example, let's take a look at this quartile plot improvement that he came out in one of his books and said, this is what we need to use instead of box plots. Can anybody tell that like parts of that are not the same as other parts? Oh yeah. All right, so Brian's familiar with that book. I look at that and I'm like, this is outrageous. I don't think that this would be better in terms of human perception than what we have already. So let's just keep that in mind as I go through his stuff. I'm also only going to be talking about some of his more concrete theories. He has a lot of really important ideas and things that maybe can find their way into helping you at some point. But I think that what I'll talk about today is what I think is most effective, or it's probably the easiest for you to actually apply in some of your work. So in general, there are some evaluation criteria that I'll cover, and they fall into two different sets. Tufte has this idea of what's called graphical excellence, and I'm really only going to be focusing on the element of excellence, which is known as efficiency today. And it boils down to ideas about how to use time and space to determine whether you're doing an efficient viz. There's another broad criteria of evaluation criteria, which comes from a different set of people. Jock McInlay, who made some contributions to this idea. He's actually famous for the idea of two categories, expressive versus effective criteria. Tamara Munzner is also a really, really, really incredible visualization and design thinker. And she gave us the summary that I've shown here. And then Jacques Bertrand gave or he made the foundation of this idea of how to choose an effective visualization. So just briefly to explain a little bit, expressiveness is generally considered to be whether you capture certain attributes of data. So for example, if your data has a natural order to it and you don't make a visualization that conveys anything about order, it is not expressive in that sense. So that's probably the easiest way to consider it. But there are many types of visualizations which could be expressive for your data. So we need another criteria that goes beyond it, which estimates which of those expressive visualizations helps us to understand what's better than another thing from the direction of visual perception. So that's where the work of Jacques Bertrand is going to come in. So I'll get into that as we go further. So let's just start off with these efficiency ideas. So Edward Tufte has this idea called data ink. Everything in your page when you're making a visualization uses ink, but not all of your data on that page is actual data ink. So let's think about this chart that's on the right. Can people see my mouse? I forget how this works.
Yes, we can see your mouse.
Oh, thank goodness.
On top of the plot on the right.
Yeah, exactly. So I hate to say it, but this scale, this helps us get context for the ink that our data is connected to, but this ink drawing the scale is not data ink itself. I'm not going to say that we should remove it, but in terms of efficiency, Tufte is always like, if you wanted to be the most efficient, then only draw things that have data associated with it. So that's sort of the way that we can think about it. We have total ink used in the graphic, and then the amount of ink that's used for actual data, like these points in the scatter plot, those are your data points. So they represent the data ink. So I would say the ratio of actual ink on this page is pretty close to 1, but it's not 1. And there are much more extreme cases where that ink ratio, if it gets too low, then you might need to start thinking, are there alternative choices that I can be making for my visualization? So I think I want to say don't aim for 1.0 as a proportion, because in this case, that would mean taking out scales. I want you to have scales, but keep in mind that if you're dropping below something like the 0.7, 70% of your data is not, data ink or something like that, you need to reconsider some choices about your visualization. The other thing I was going to mention is a lot of these ideas, these decisions get made for you by certain plotting libraries. But if you start really diving into certain options in those plotting libraries and adding or removing things, then you need to be aware of this idea of data ink. The second idea, and this is where we're going to actually do a little bit of group participation, is we are going to consider the data ink in this chart. So using space, of course, is using space wisely is always important. But I think that this general practice is important also as a visualization technique, because you have to present your work to others early and often in the development process to create good, or excellent viz. So let's take, I see my timer, and let's take 2 minutes. And I want people to think about how ink is being used on this page and where ink is being used that isn't data ink. Sound good? And at the end of that, go ahead and type your thoughts into the chat. 2 minutes might be a little long. I'll give people 30 more seconds if that sounds good. All right. Yes, starting with Brian. All right, if folks are ready, go ahead and type in thoughts. It's totally fine if you were thinking about something that someone else has already typed. I think it's just fun to like see if everybody was on the same sort of thread with their thinking. Oh yeah, the 3D charts are getting hammered. Makes it less clear. Yeah. Ah, the drop shadows. I was about to say, ink is being used for shadows. You could have a 3D chart without shadows, but they went even further. They were like, yes, let's make it photorealistic. All right, let me see. I think this chat's going a little faster than I can read. Yes, okay. And I've the legend elements repeating is a sort of a great call out. And one thing that's kind of frustrating is we've done a lot of work to try to figure out where this chart came from. It doesn't exist on the internet according to TinEye and Google reverse image search. But my advisor, Dr. Joshua Levine, who's still in the CS department, somehow got his hands on it and it's in his slides. And I still don't understand, like, why is this color thing repeated in the legends? Like, yes, that is a way of that's actually a different subject. I'm not going to include it in the slides, but Tufte has this idea where you're not supposed to show design variation if you don't have data variation. And here we have design variation. We have two different designed color categories, perhaps for the same sets of data. There might be a reason if we knew more about the chart that they did that. Also, it might have been a great thing to think about when you were revising it. So let's speak about revising a chart. Yeah, all right, let's drop that third dimension. And it makes it much easier to complete the task of understanding how do these different chart or bars relate to each other? Because with the perspective in 3D that we had before, we might have considered that bar closest to us to actually have a higher data value because it took up more space. So yeah, back to the ink ratio, this is much more efficient. Another idea, which I think actually comes built into ggplot these days, is another data ink removal strategy is let's think about where ink is being used in this chart on the far left. We have this outer box. Okay, are the horizontal lines maybe up at the top useful for communicating data? No, let's drop it. Okay, cool. Next step, is that entire vertical line useful for communicating the data? No, I could probably get away with just having some tick marks. All right, well, those tick marks don't let me, communicate information unless there's numbers on them. Throw those in, but at the same time, let's actually take away some of the ink in these bars, and that gets us, to the point where we don't actually need a grid. So this is a general flow that I think you can apply when you're being really data ink conscious, is the idea of, can I provide context by removing ink from my page as well? I think, the idea of throwing in numbers, that's not even a question for most of us. So I think this also shows its age a little bit as an example. These choices are just made by our tools. So feel free to continue with them. Don't like stress out by saying, I have to remove the percentage numbers that are on my y-axis or something like that. But this flow, I think, is a demonstration of a round of revision that you can do with your work. Just think about, can I remove things to provide additional context about my work as well? So that's enough of the data ink stuff. Let's talk about another criteria for efficiency that Tufte is big on. It's this idea of data density. So it's similar. Our eyes are really, really, really sensitive. I'm not sure how easy it is for everyone to see down there. But that square down at the bottom is an 80 by 80 grid, and it takes up about 1 inch in the textbook that I took a photo of. So of course it's maybe bigger than 1 inch, depending on the size of the screen you're on right now. But the point that I'm making is, even though we can't like read a number that's within each cell of that grid, we can tell that there is space in between these lines that are marking out the grid. That is incredible sensitivity. So let's make use of that. Our eyes are really, really good at picking out all the details. So let's not make charts like the one that was provided to the office of the president in 1973, which showed 3 bars, for twice as much space. Essentially, I'm putting on my hat of being very opinionated. I think at the end of the day, making any viz is better than no viz. So if you found yourself like making a chart that was a little bit too big of bars, that's fine. But if you were wondering what your next step in the revision process would be, it would be to consider the density of that visualization. That is a very sparse visualization. So if you have a certain number of entries in your viz, you can divide that by the number or by the area that you are providing in the display space, and that will give you your density. And I just want you to take away that the rule of thumb is you can reduce by about half for most of your visualizations and still be able to interpret it or let your audience be able to understand what's going on in there. So this also leads to a lot of ideas about repetition of visualizations. I'm not going to go into it specifically. I am going to go into it specifically. The idea that sometimes reducing the size of one visualization allows you to add in an additional visualization. So this is what's used in the technique called small multiples, where you essentially create the expectation for a viewer that the context of your viz is going to stay the same between multiple repetitions, but the data is going to change. And this allows our eyes, and our visual perception to pick out changes really, really fast. It doesn't help as much in this bottom left category of all the different signaling systems for a little tram system. But on the right, this is a visualization of where skin cancer shows up on people, male versus female. And in my mind, I'm like, oh, wow, look at this. Male pattern baldness right up there on the top. So like that took no time at all to extract a certain pretty important thing about the differences between gender for skin cancer. And this is the idea of if this had been an entire visualization, our density would have been low and we wouldn't have been able to communicate quite as much information at the same time. So again, this work comes from Jacques Bertrand, who is essentially saying, yeah, pack it, wherever you can, make your visualization small and add in additional pieces. I also like the quote that comes from other people in the field, back to data Inc. and things like that. It does connect to data density. For non-data Inc., less is more, like get rid of that stuff. But for data Inc., if you include less, that's boring. So, I know it puts the onus on you to come up with more material visualization-wise, but on the whole, it's going to lead to more excellent viz. So that's just how those ideas connect. Oh boy, 20 minutes in. So now let's pivot away from Tufte and his work, and let's actually talk a little bit about this idea of expressiveness and effectiveness. So I'm not going to go deeply into the expressive criteria because it can just be boiled down to the idea of if your data has certain attributes, like it's ordered data, and your visualization communicates that, then it is an expressive visualization. But many visualizations can be expressive. How do we decide which ones are the best ones to use? In comes this idea of needing to estimate effectiveness. And underneath that, we have to consider these 2 different criteria, marks and channels. And as Renata reminded me, geom stands in for the word mark, and aesthetic stands in for the word channel when you're actually using ggplot. So marks can be boiled down into these dimensions. So a 0-dimensional mark is a point. A 1-dimensional mark is a line, and a 2-dimensional mark is some sort of area or network representation of your data. So that's really the basic concept of if I have a screen, what are the things that I can draw on that screen? So the next question relates more to how am I going to draw those things? Like I've already chosen a mark. A channel controls everything about how the mark appears on the page. So it's an appearance controls. Position, I can sometimes think of as, it feels a little bit weird to consider position and color to be in the same category, but they are variations of a mark. A mark can have a horizontal, a vertical, or combined position channel. It can also have color, shape, tilt, size, all these different things. So it's interesting to consider that, we have all of these combinations. So then why don't we start thinking about, all right, if I know something about my data, which one of these, channels should I start to use? So in general, and I think that this can be flexed a little bit in your visualization, but the things that I've drawn little pink boxes around, these are good channel choices for things that are categorical or identity types of data. So if you want to, indicate that one thing is different from another thing, but there isn't sort of a magnitude associated with that difference, you want to use position, color, or shape. If you actually know a magnitude for your data, or your data is considered to be quantitative or continuous, then the blue boxes are great channel choices for them. So that's already helping to separate out the channels a little bit. But if we are thinking about maybe the set of pink boxes or the set of blue boxes, is there an order to which these things might be better recommended? So this is where the work of Jacques Bertrand and McInlay really come in. They did a whole run of studies. I mean, this work has continued since about the 60s, so not that long ago. I think some of the work in 2010 was actually using like the automated Turk system, where they were giving people tests and sort of estimating, between the choices of these different channels, how efficient or how effective, how quickly can people make certain takeaway or make certain estimations about their visualization. So here on this page, this I'm gonna say it. This is probably one of the most important pieces of the presentation for you to keep in mind or look back to. This single slide, ordered from top to bottom, the most to least effective choices for these channels. According to visual perception, we are just super good at making comparisons of position on a common scale. So if two things for a contrasting task or a comparing task are presented this way, nothing else is quite so fast for us to draw information out of it. It goes down from there. We can still make certain valuations when there's an unaligned position scale. And that is close to, but not quite as bad as using length to encode information about how much. So it would be, imagine trying to compare these two different lines to each other. It's still easy enough to see how they are. But, if we step up in our channel choices to a different option, things can be faster and more effective. You'll notice that, and I am totally guilty of this, volume for encoding how much or magnitude or quantitative information is like the hardest for us in our visual perception. There are ways that I think, in one of Tufte's books, I tend to not focus on this because most of his work is taken from like the 1970s or before, or a lot of it is when people didn't have tools that made certain visualization choices for you. People used a lot of area and volume presentations in their infographics. And every single one of them made it into his book as an example of what not to do. So I think this is sort of supportive of Tufte had a lot of strong opinions. Then other people in the field came along with actual scientific work and studies to support that, some of those opinions. So if you find yourself reaching for a volume encoding, seriously consider if there are other ways to be making that visualization. On the other side, we actually have the same sort of information broken down into categorical information. So if you can separate things out to actually be spatially, discriminable, or you can separate them that way, that's the fastest for a human to be able to perceive that there is a difference. Color is right behind that. Motion is an interesting choice. You can actually make an interactive or an animated visualization, and that will help to encode that some of these points are different than others because only some of them move. Now, shape is something that we'll see in most papers, but unfortunately, it's down at the bottom. Like there are a lot of better choices for providing information about if something is different than another thing or like its identity. So again, I went on that slide for a little while, but I think it is one of the most important pieces of information in this presentation.
Can I just
yeah,
ask real quick, the size thing, I vaguely remember now reading something about this. Is this because that like a circle, for example, that has twice the area or twice the diameter isn't perceived as twice as big. Is that right? Okay.
Yes, yeah, exactly. Yeah, we we tend to have sort of they did this, it's like an inverse power law relation to how perceptible those changes are. So we will equate like a circle needs to be some factor much higher than just 2 times its area to be perceived as twice as big. So that's exactly.
Yeah, for those of you that were in the first session of this, when we were looking at that Gapminder plot and somebody pointed out that there's some statistical transformation that was relating population size to the size of the circles. And so that's where I think probably that research comes into play, where somebody's figured out like some calibration curve for circle area human perception that is like pretty good, better than just scaling the area or the diameter or something like that. And yeah, that's
but it's at that point where I'm like, if you're starting to find yourself dipping into these different encodings, these different channels, it really might be time for a second plot.
Right.
All
cool,
right.
Thanks.
I have a question too. Sorry. So I think generally like pie charts are considered not effective visualizations. I think hopefully everyone here knows that. Where would that fall on this list? I was thinking like area, but that doesn't quite make sense.
No, it's totally area.
That's not as far down as I would have thought it would be based on sort of like the vitriol people had towards pie charts.
Well, the reason that the pie charts that people are the most frustrated at are the ones that have like way more than like 8 categories and stuff like that. And I think that at that point, we're really just talking about a broken choice. Like, an area or a pie chart that has maybe 3 sections or something like that, or even a ring chart where you've cut out the center, which provides, a little bit more of a rectangular representation instead of this weird chorded shape, this polygon that we have a hard time estimating the area within. Those are better choices. I mean, all of them are, I think pie charts also tend to be the things that people will see in 3D, which throws off everything. I think there's a really famous example of Steve Jobs using a pie chart in his presentation and putting Apple the closest to the perspective. And it actually was less than one of the other categories, but because of rotating the pie chart in 3D to fit that, it appeared bigger. And like that was very much their goal. But I would say, it's one of these area things, unless you're in 3D, and then it's a volume, and then it's even worse. So
yeah, there's a comment in the chat about that from Brandon.
I see that. Is anything rated lower than a 3D pie chart? Yeah, no chart at all. Sometimes. I mean, it's an interesting question. If I were to say no chart at all, then that's going back to like the beginning where I said, here's statistical summary. There are really good times to just give people some numbers, right? Like if I back up to, the demonstration of data density, Tufty is saying this is the best thing I've ever seen for representing a baseball season, and most of that is information that to a baseball viewer, they would understand what these numbers are all about. I don't get that, but yeah, I think, humor aside, I think sometimes I'm here presenting information about best practices, but what I really also want to normalize is the idea that we're not all going to make every chart perfect. And I think the other thing that's rated lower than a 3D pie chart is a chart that you've created early in your process that you won't let go of after hearing it's not the right chart. So, sometimes you need to iterate, you need to not be precious with your creations, and I'm guilty of that too. But part of the reason why I'm talking about now in this slide, all of the options is to make it easy to consider alternatives so that you can move quickly and start to consider what could I also try that will then help me gain perspective about whether the thing I made before is the best choice or, is maybe the best at the time. Or was the best at that particular time. So this resource is data2viz.com, and they are a flowchart. It's cute because their graphic is a visualization too. It's representing sort of how they, thank you for putting that in the chat, how they want people to sort of tackle the question of, is the chart I'm using sort of amenable to my data? So on this website, we can scroll down and actually have this presentation. Oh, I remember I have that in the actual slides in the next slide. That's fine too. But what you're supposed to do is you're supposed to pick up here at the top one of the categories that best fits with your data. Is your data numeric? Do you have categorical variables associated with it? Or is it a combination of them? And when I select one, we see this flowchart where it asks me some top level questions. Do I have one variable in my data that I want to make my chart out of? Okay, if so, then it's recommended that I use a histogram or some sort of density plot. Do I have two numeric variables? Cool. All right. Is there an order? No. Well, those of us who have done the basic plots out there are like, oh, great, a scatter plot. That's awesome. But look at that. A histogram might also work. I think that they will back it up with some more information about why that also fits in this category. But this resource is meant to sort of help you understand. These are not the only visualizations that are out there, but this is a large portion of them. And what's nice about them too, which might help later on when we're going into the actual R stuff, or when you're doing the R stuff, is you click on it and it will give you actual code related to it. You can click on the R graph gallery link for a connected scatter plot, and it will actually show you how to make that. So I think this goes with what I want to recommend is your flow. And I do need to get to the last exercise in our time to make that work. We're actually pretty close to 40 minutes, which I wasn't expecting to reach.
Definitely don't need to rush.
Yeah, I won't. I think this has been exactly the pace I wanted to go at. I want to talk about this entire flow of how I perceive people iterating on their visualizations, and it begins with doing a hand drawing. And before we do the hand drawing, I'm going to say what I think the next step is after you've made a hand drawing, go ahead and try to get your hands on some examples from a gallery and look for parts of your hand drawing that fit in with somebody's already working example, because the most frustrating thing and the slowest thing that can happen is that you can start trying to make something and it's broken, and you're trying to get from the broken state into the it's working state. And that is the most frustrating thing you can experience. I recommend trying to stay in that it's working phase as long as possible and making small tweaks that bring you closer to what you're trying to do. So anyways, now that my little spiel about what I think is probably the right way to go is done, I think the first step for most visualizations really should just be you with, your pen and paper, making something that is horribly off from, the beautiful thing that a programmatic visualization library could provide to you. But why are we doing that? I think it forces you to think about what you're doing first, or even like what you're trying to communicate before you start messing around with anyone else's tools. There is a time and place for exploratory data visualization, like getting an understanding of what's actually in your data. But I think if you just sort of centered on this, make some sketches, if you ended up needing to ask for help, this is also the most useful thing that someone like me or one of your other course providers, this is going to help them understand what you're really interested in. So on my next slide, I'm going back to this example again, temperature on the different solstices. And I want us to do a hand sketch. So we're going to take like 1 or 2 minutes to do this. If you have paper around, that's awesome. The plan is to, at the end of that, have each of us sort of turn on our camera or hold up our sketch, and then we can just briefly talk about it. So I'm also going to do this with you. I don't get to escape the potentially exciting and embarrassing moment of being like, all right, I've just totally misrepresented how this data looks. But what we want to do is just take a minute and draw out whatever visualization. I'm being specific. I'm being very general right now. Whatever visualization you think fits to explain these 2 columns of data. So I'll start my timer, and 1 minute from now. Oh my gosh, I totally missed that a minute had already passed. I'm just gonna finish drawing my little dots. Okay. I don't think I did this correctly at all, but it's at least going to attempt to express something that I wanted to explain. So, does anybody feel like they want to share what they made by holding it up to the webcam? And I might take my screen share off so that I can actually see other people's things. I think the background subtractor for Zoom has like, it always plays a little havoc with this. But I don't have mine on, and so I might also hold mine up. Oh my gosh, it's a little hard to see. Yay, I'm seeing a lot of scatter plots. Awesome, awesome, awesome. It's still like replacing Christina's. That's funny. Yeah, awesome, everybody. I see some of them connected with lines. That's great. How many people are holding like an envelope that they drew on the back of? Nice. Cool. Great, everybody. Thank you for humoring me. Oh, I love it. I love it. I'm seeing some different variations. Yes. Yeah, great. Okay, cool. So, I mean, unless anybody feels really, really strongly about talking about theirs, I'm going to briefly talk about how mine. I am often torn between this idea of including 0 in my y-axis, and I feel like in this particular case, you know, there is an effect in here that might be worth explaining or showing, but it also might be important to say that in the true scheme of temperatures, this is, you know, not a giant spread. But for us, it feels that way, and so I also included a smiley face, you know, up, down at the lower temperature and a frowny face at the top temperature. And so there's almost a categorical element to this as well. Simple histogram, x-axis is year, y-axis is temperature. Awesome, Brian. Well, this is great. I'm happy that everybody did that with me. And I think that's most of my time before I come back at the end. But it's been wonderful to chat with you about these different ideas. And this is really just, it's a tiny fraction of what's out there in the world. But I think at least it might become information that's referenceable, because the other stuff can be more abstract and it can require a lot of design thinking and things like that. But I'm now going to step into, actually, I have one last slide, which is my sort of outro slide. Oh, I am now showing the presentation notes from screen. But yeah, so I'll come back and we can do the final exercise together, but I want to just explain, thank you for your time. I'm in the research technologies department, do workshops like this. I also help out with independent study and capstone mentorship. Talk to me if you have consultation questions, and if you have variable length collaboration projects that you want to do too. We used to have stats consultants. I think as of this week, they have just been, they're another casualty of the IT centralization. They've moved to the biostats group. They're no longer part of UITS. But if you end up needing to use the supercomputers here on campus, we have HPC consultants for that too. So yeah, thank you, everybody. And my contact information will be available at the end of the meeting.
Fantastic. Thank you so much. This is really great stuff. I'm going to suggest that we take a 10-minute break and come back at 5 till the hour for some coding practice. Yeah. See you all in 10 minutes.
Oh, and I'll mention, if you have questions, put them in the chat and I'll be around to answer them off the main channel. Oh yeah, Josh's class. Josh goes into a lot more detail on these different things. So he teaches actual data visualization for undergrad and graduate in the CS department. It is CS 444 and CS 544 for anyone who's interested in taking an actual course on this. So good reminder, Christina. Thank you.
All right. Hopefully folks are starting to trickle back in. Hopefully y'all get a chance to step outside or look at something other than a computer screen for a few seconds. We are going to go ahead now and talk a little bit about how to do some of these things in ggplot2 before coming back to a little bit more higher level example of thinking through how to approach visualizing different data sets. So first off, there is a script available for if you'd like to run the code now or later to do everything that's going to be in these slides. That'll download our script right to your computer. I just put it in the chat. I am not going to be doing too much live coding because I don't necessarily think that the most important thing is like typing out all these arguments so much as knowing what functions, which functions are there and how they translate into changes that you see in your plots. So you can just watch along if you'd like the script to follow along now or later. It is yours. Great. So for this section, some of the things we're going to go over. We want to be able to implement the principles of effective design that we just talked about using ggplot, including using the options in ggplot around themes and facets to maximize data to ink ratio. And then use geoms and aesthetics, which translate literally into marks and channels in ggplot to make choices about how to show data. And I'll briefly want to let you know about a couple of helper tools. That's culs for all. Cul stands for color, and I guess esquisse. I have never actually said that out loud, so I'm not sure how. And I think it's made by, I think the research group is French, so I'm probably completely ruining that pronunciation. But those are two sort of visual interactive tools that you can use with R to inform your visualization choices. And then we'll come back together at the end and work through an example. So some tips and tricks in ggplot2 for maximizing your data to ink ratio. This may be familiar to you as the sort of default way a plot would look in ggplot2 if we make a plot and we don't change anything about it. So in this case, we're plotting some data about penguins. This is the Palmer penguins data set, if you're familiar with it. On the x-axis, we have the body mass. On the y-axis, we have the bill depth. And then it's colored according to the different species of penguin. And this is a sort of basic ggplot. So maybe familiar with this color scheme and with the gray background. You can use these like pre-baked theme functions to modify a plot to make a bunch of changes all at once to the sort of base way the plot looks. So one I've used a lot in my life is theme BW, that stands for black and white. And it changes a whole bunch of things. It gets rid of the gray background. It inverts the color, or inverts the axis grid colors from white to black. So you can do these kind of fell swoop changes to the plot with just a single like themed BW that you add to a plot with this line. You can take it some further, so you may notice that this plot still has a lot of ink on it that isn't necessarily directly related. Like, I don't know if we need these like faded grid lines. There is the theme void if you want to get rid of all of it and just have your points of data floating in the void. It might, like, we could definitely talk about this. This is probably a little too far. This is no longer informative about what these data are or what each point actually means. If you want a complete list of the themes, you can use the question mark theme void. Will get you to a help page that has all the themes, and there's also the ggplot2 documentation is going to have a complete list of the sort of built-in themes. The thing about the themes is that so yes, this is a takeaway about the themes, that you can use it to remove a lot of unnecessary ink with a single fell swoop. And you can do it with like outside of your plot code. If you use theme set, you will change the theme for a whole script or our markdown notebook. But the thing about the themes is that the preset themes either leave us with maybe a little bit more extra stuff on the graphic than we necessarily need, or they remove badly needed information. And in most cases, you're probably going to want to go beyond the sort of built-in theme options to modify individual elements of a theme or to modify individual components of the plot. And the thing about theme is there's like 7,000 arguments. It can be a little bit bewildering to open up and try to figure out how to change what the things that you want to change about your plot. So we're going to break it down. So the theme function in ggplot is going to take direction from you in this general structure, which I hope is easier to understand once I talk about it. So we call theme and we identify some part of the plot, and then we modify the part of the plot by setting it to be an element, and there are different types of element, and then supplying options about that element. What do we mean? So the parts of the plot can be things like the axis text, the axis tick marks, can be things about the legend, like the box that the legend is on, or the location of the legend, panels, like the shaded areas of the plot itself for like titles and strips. We'll talk about facets, but so different sort of like pieces of the plot. And then these components of the plot are made up of elements. So for example, the text that says the plot title is an element text. It is like a text box. And so we will set you could set, for example, the plot title to be an element text, and then supply some options to that element about how you want that text to look or how you want that text to behave. Similarly, like the marks that make up the grids in a graph are going to be element lines. The background panel for a graph is going to be an element rect. It's an element rectangle. And often if you want to just get rid of something, you make it an element blank. And you can modify all of the elements of a certain type in a plot by setting like all of the lines, by setting all of the lines in a plot to be like a single element line. There's this hierarchical designation of elements, which we'll talk about more. And a really helpful tip for dealing with the theme function is to look at the documentation for theme on the web, as opposed to in the help viewer of your R or RStudio, because the render documentation has lots and lots of information and then has examples that you can look at to see how, for example, adding the background to be a green rectangle shows up in a plot. So here's an example where we're using the panel background component and element blank to get rid of the background panel. So here, this code is creating a basic off-the-shelf ggplot, and then by adding theme and saying we want the panel black background to be an element blank, there is no more gray shaded background. Similar logic applies. We can add elements back in. So in the basic ggplot, the grid lines to make up the plot are white. And so when we made the background blank, the grid lines are invisible. Here we're saying we'd like there to be grid lines again, please, by saying the panel grid major, which is the minor grid lines happen at finer scales, is an element line, and we tell it the color and the width of the line. And each of these different elements is going to have a different set of options you can tweak about it. So for the line, you could probably change like what kind of a line. Is it dashed? Is it solid? For something else like text, you can change the font size, etc. This specifically is probably not the optimal design choice for this plot. I don't think we need these like massive grid lines, but this is how you would change them if you'd like to. And getting back to that thing I mentioned about the hierarchical nature of these modifications. So the components of the plot that you can modify in theme have a hierarchy to them. So we can set, and they go in order of like most general to the whole plot to most specific to an element. And so what I mean by that is we can set a setting for the panel grid major, which is going to set for all of the grid lines for the plot, X and Y. And then if we want to make a more detailed setting for a setting for a more detailed component or more specific component of the plot, we can add this line modifying panel grid major X. And here I just turned it red so it would look different, so you could see how we had modified it, and we made it a little bit narrower. So this can save you a lot of time if you want to just like set things at a very coarse level, and you can get increasingly specific working down through the hierarchy. And you can get a sense of what that hierarchy is if you go up to even just this list of all of the possible components. This here is a list of all of the possible components you could modify about a ggplot. And you'll see how they go from example axis title. This would modify everything for all of the axis titles, down through the more specific titles for the axes. Same for text, tick marks. They have this like fractal or like hierarchical nested structure to them.
So I have a question, sorry.
Yeah.
So changing the order in which you have these different theme pieces wouldn't then affect how it looks, right? Because they like, it wouldn't like over, like
so.
if you put the element blank for the background at the bottom, it would still probably show up the same. It wouldn't like override that.
The exception would be if you were to then put a theme, like theme BW or theme minimal.
Oh, that would
In
like
my
override
experience,
everything.
those do overwrite like most other modifications you made to the theme.
Cool.
Yeah,
Awesome.
I have done that to myself. Fantastic. As far as the one of the major strategies for maximizing use of space, that's going to come down to what we call faceting in ggplot2. So this is an example. There's two ways to facet, but what the faceting will do is it will break apart your plot into multiple parts, multiple plots, based on some variable in your data. So here, these data have a column for island because these penguins live on different islands. And we've faceted based on the island to get ourselves 3 different plots, one for each island, showing the relationship between body size and bill depth for the different species of penguin on each island. And so this has given us like smaller plots. It's given us that same idea of small multiples, and that we have shared, I think I'm getting this right, we have shared axes across all the 3 different plots, so that it's pretty easy to see for a viewer how the like penguin sizes and bill depths, whatever that means for a penguin, maybe that modifies what kinds of fish you can eat. I don't know. It's probably important to a penguin. How that varies across the different islands without doing a lot of like additional processing around like what do these orienting to the different axes. Faceting, you can control the way the facets are displayed. You can, for facet wrap, you can offer these like ncol or a corresponding nrow argument. So by adding ncol equals 1, we've said to, instead of allowing there to be 3 columns, force there to be 1, and we've coerced it to this vertical alignment. There is also a facet grid, which I find particularly useful if you want to start faceting on multiple variables. So in this example, we have both female and male penguins, and maybe we want to also start displaying variation there. So we can use facet grid and tell it to facet by one variable for the rows. So we've split into different rows for the different islands, and a facet on a different variable for the columns. So we're faceting on sex for the columns. You can control how the facet labels are oriented with this switch argument. If we said switch both, we would get the sex labels on the bottom and the island labels on the left. We said switch Y, so it just moved the island over from the right over to the left. And lastly, there is an argument to the facets that you can use if you so choose, which is to set the scales to be free. They can be free Y or free X. And what this will do is it will allow the different facets to have different Y axes. So you can see here that one island, the Y axis begins at 16 and goes up to like 24 maybe. And then another island, it's like broken up differently. This is an argument to use judiciously, like only use it if it makes sense for your data, because it's also a really good way to advertently or inadvertently confuse or mislead someone who's looking at your plot who may not realize that the axes are shifted based on the different subplots. Getting back to theme, you can also make modifications to how specifically the strip in a faceted plot is displayed. That strip is the area where it's we just describe the different facet labels. So if you recall, that facet strip used to be pale gray, and if we change the strip background, we can make it blank to get rid of a little bit more of extra filler on the page. And lastly, you can use the theme to modify how the legend is displayed. One of the ones I use the most is just move it around. You can also change things about the appearance of the legend and how things are stacked. As we've mentioned, marks and channels in ggplot2 are called geoms and aesthetics, which is to say that the geom is, if you're like geom points, lines, calls, you can have lots of different geoms. And channels, we use the AES argument in ggplot to map geoms or marks to elements of our data. So some of the aesthetics you're going to use the most are going to be X and Y for position, color or fill to give the color scale, which can be discrete or continuous. Alpha is going to get you opacity, which is as close as I can think to luminance or like color saturation. We tried to figure out something more technical for that, but it's not there. And then size for the size of a point or something. And especially this will be familiar to you if you've played around with ggplot a little bit. You can also set an aesthetic manually if it's not mapped to data. Based on the discussion earlier, that may or may not be something you want to do. If getting back to the idea of like, if there's not data variation, why are we putting variation in how we're displaying it? And there can be valid reasons for that, but something to think about. So here, basically riffing off of the chart Devin showed with the the most effective to least effective modes of communicating different types of data. Here is an example that was me attempting to come up with marks and channels that are perhaps not ideally suited to displaying the data being communicated. So here, bigger dots are bigger penguins. And yes, this is a geom jitter plot. So the jitter, what this does, so okay, so here we've done, you're using points, and the size of the point is mapped to the size of the penguin. And the y-axis is different species, So we've put them in different locations on the plot by the different species, and then we've put them on different locations based on sex. But because that would give us a whole bunch of points, right? We have like maybe 50 female Gen 2 penguins, and they would all have exactly the same XY coordinates based on this. The geom jitters points around so that if they would appear like stacked on top of each other like a stack of pancakes, they get spread out so that you can see them separately. And so this is essentially showing how the sizes of the different species and sexes of penguins are distributed by looking like a child poured some tiddlywinks on the floor and trying to assess which tiddlywinks are bigger.
I think this is like a really nice demonstration too of what y'all were talking about earlier with like us as humans like not visually being able to tell like the difference in area, like the actual change in value versus the difference in area. The first time I saw this plot, I became very angry intuitively, just because I knew it was not the best way to represent this data. Anyways.
Yeah, mission accomplished. And to the chat. All right, good. And this is potentially a slightly better way. It may not be the best way. And this is something that it would be great to put more thought into or to continue like practicing thinking about here. But I think a much more common way to show this would be with something like a histogram where we're using, I suppose, the size of the bars to represent amounts of penguins. Although I guess you could also argue that it's kind of the point at which the bar ends. We're splitting out the categorical information spatially on the page. So female Gen 2 penguins have their place, female chinstrap penguins have their place, male Adelie penguins have their place. And then the sort of shape and distribution of density shows like how the sizes are distributed across this axis of like how big penguins are. So it's a more familiar visualization, and if what we're trying to communicate is, I don't know, that the biggest penguins are male Gen 2 penguins, this is maybe a more adept way of communicating that. As far as, and here's another example of just using different strategies for differentiating categories. This is one that you may encounter quite a lot, especially in like the publication world, where trying to use shapes to express differences between categories. Pretty common. Also, so here circles are Adelie, triangles are chinstraps, and squares are Gen 2. The squares kind of stick out because they hang out in a totally different corner of the plot, but differentiating between the Adelie and chinstrap penguins, you have to do it point by point, or I have to do it point by point. Whereas with the color variation, instead, it's a little bit easier to grok. This gets us into the conversation about, oh yeah, hard to see. Yeah, they're also kind of small given like the dimensions of the plot, and I think it something that I am thinking about is it would be good to have a conversation about how to change how big a plot is rendering. I didn't do it in these slides because of how we're rendering them. But when you're outputting something for a publication, you can get a lot of mileage just by making it real small. Or like high resolution, I guess. But so if we are going to be using color as here to differentiate between different categories, we need a color scale that's actually going to be effective for doing that. And there's lots of different color scales available for you in R. And beyond, and there are some that are just like, there's one that's like Miyazaki themed. There's a whole library that are Miyazaki themed. So you could have a Totoro themed plot if you so chose, or you could have a Spirited Away themed plot and you would know the difference. Beyond the sort of whimsical aesthetic differences, color palettes can be sequential. So colors more towards like, I don't know, like the blue end of the spectrum, am I going to get this right, are going to like look one way, and then like the, it has a directionality to the spectrum, categorical, so something that is like more blue or more red, that difference doesn't really have any meaning to it except that they are different. Diverging, so things get more different, or bivariate, which is like multiple axes of variation. And so it's important to choose a color palette that has the appropriate like structure to it. And then to take into account that not all color palettes are going to be equally accessible to all viewers, depending on differences in sightedness and how our eyes perceive color. And there is a tool out there for R called Calls for All, which is an R package, which is really just a GUI, a graphical user interface tool for exploring the wide world of color palettes available for R. So you can interact with Calls for All, you install the package, and then library, and then you just use this little function to launch the GUI, which I am going to go do. And so you can show you what happens in the GUI. It's going to take me a second because my R is a little bit recalcitrant.
We can still only see your slides on the screen share too. I don't know if that's intentional right now. Okay.
Or it is what it is. We're getting there. I should probably have had this running before. We'll share. I am going to just, because it's going to be a lot of windows hopping around, I am going to launch the Calls for All GUI and then share that with you. Run in my console in R C4A GUI, and I will share the pop-up that generates. So that's going to generate this little shiny app, basically, that's a way to explore color palettes based on what attributes you would like them to have. So you could choose something that's, you can look for a bivariate color palette. You can filter based on how they, and shiny just crashed.
I have it open on my screen if you want me to share. You can just
that'd be fantastic.
Tell me what to point at. Or I can walk through it. I don't know if there are particular things.
Oh, I didn't have an agenda. If you have, yeah.
I'll just show, I mean, I think the thing that's that took me the longest to figure out is that these icons, if you hover over them, you get little tooltips that tell you what they mean. So the little eyeballs here says, be careful, some colors are hard to distinguish by colorblind people. See tab colorblind friendliness. And like, for example, under the vividness here, this like snowflake asterisk thing says pastel colors, low chroma, ideal for space filling visualizations such as choropleths, which are like maps, see HCl analysis. So you can hover over these to see what they mean. And you can also sort by those columns. So if like the most important thing for you is that they are fair colors, you can like sort by fairness, and then probably would want to reverse it in this case. And so fair here, this heart means that these colors are equally vivid and bright. So they're like perceptually even. And then the other thing I would just, you can sort of look for, if your color palette needs to have 20 separate colors and be, categorical, well, you can kind of like filter by that. The other thing that is like hard to figure out if you didn't, that took me a long time, is that the hex codes for the colors are there. They're just, so you can select these. It's probably hard to see on Zoom, but as I select these, I could copy and paste this, and that gives me the hex code for that particular color. If I didn't want to like figure out in the help how to use this actual palette, which there is a way to do that. You could use this like scale color manual that we talked about in the first session.
That must be like an error on the developer's part to have the hex codes like invisible.
I'm not
You
sure.
think?
I couldn't figure out what these icons were, and I opened an issue on it. Like I thought it was a bug, and then they were like, "Oh no, you just have to hover over." So I think there's just some design choices for this that are like a little hard to figure out.
Yeah. Yeah. Not,
And then the
not
other
necessarily
cool
intuitive.
one is like the colorblind friendliness. So you can choose a palette, one of these palettes that you've sort of filtered it to, and you can see what it would look like for folks with 3 different types of color blindness to sort of double check that your color palette is colorblind friendly. And there's lots of other fun stuff to look at. There's like this weird, I don't know, this is like some kind of optical illusion that happens with certain colors of blue. I don't know. There's all kinds of cool stuff.
Yeah,
Anyway.
this is fantastic. This is great. Yeah, so that is a tool for you to use, and it makes a lot of these decisions like much easier to like navigate if you don't have this expertise, because I don't. It's much easier to find something that's going to meet your needs, and you can then Codes for All, you can then use some of these color palettes like right in a plot. And the second tool that we wanted to show you, because I think it ties in really nicely with the data to viz flowchart that Devin showed earlier, is this tool called Esquisse, or however you're supposed to pronounce this, which is probably not how I'm pronouncing it. Similar to Codes for All, it's you can install it and add it to your ggplot. Here's a link to it. It is a interactive tool for exploring data viz pairings. It's technically an extension, which we'll talk about more next week if you'd like to join us. To use Esquisse, you install it, and then you're going to run something like Esquisse, I suppose, penguins. And I'm going to go run that, and hopefully my R lets me do that, and I'll share what happens when you launch Esquisse. I don't know how you say it. I am on the penguins data, and penguins is the data that we're working with. Share. So this will launch this little interactive tool where you can start to play with generating a plot given the variables in your data. So this penguins data set has columns for species and island, bill length, bill depth. These are the columns, and you'll see it's labeled them based on whether they're these are character, categorical, and these are numbers. And then you can play with dragging and dropping them to generate a plot. So we've looked at a lot of plots of, what was it? Body mass on the x-axis. And if we just put one variable on the x-axis, it's going to suggest that we visualize this as a histogram. If we want something more two-dimensional, we've looked at a lot of plots with the depth on the y-axis. And now it's showing us maybe this could be a scatter plot. We could start to, let's say we had them colored by species. And we're starting to get, I wish I could make this bigger, but it's not allowing me to. You start to get the color scales that we had in the plots I was showing. But you could do something, we could facet this by island and get our 3 different facets. You could explore what this whole visualization would look like if you used a very different version of the visualization. I am intrigued by what happens if we show this up as an area plot. horrifying. Yeah, so the drag and drop. I have actually never used Tableau, but I do think this is my understanding of it.
The line plot doesn't make a whole lot of sense because it's not like a time series. But if you did have something
Right.
where that made sense to connect the dots, right, that would be something to do.
Or for example, if we tried to make a path plot out of this, this would be an example of showing a relationship in the data that does not exist, which is these are just penguins. The penguins are not connected in any particular way. And unfortunately, I think because of the size of my screen, I can't get back to a point plot.
Can you go to the auto? The auto is grayed out. Interesting.
Yeah, so I might need to, maybe if I remove things, eventually it will reset itself. So this can be a tool for essentially like putting your data into that data to viz flowchart like framework. You can play with different methods of showing the data. You can try on having a facet, and then once you have a plot that you're comfortable with, so let's say we just have the plot that we'd been showing, I inverted it by mistake. The plot that we've been showing all along, you can Esquisse can give you the code, so that it'll translate this thing that you created with like drag and drop into the code that you would need to implement this in ggplot2. So it can be a really helpful tool for sort of designing a visualization and then having the code to reproduce it again later. I go back to slides. And so now I think we have a chunk of time to go back, Devin, to the exercise where we could put together some of this principles and the maybe a little bit of tools. I mean, I have some data downloaded, so I could throw it into Esquisse to work through the idea of, yeah. So if you want to take back over with the example, I mean, I think that's all the content that I had to share. We can certainly like talk more about nuts and bolts of ggplot2, but I think it's a great exercise to work through. So we can go ahead and use the rest of our time together on that.
I'm cracking up because in between I managed to freeze up my system that I was presenting on. So let me.
Oh no. I mean, I can probably just, if you want to share a link to your slides or something.
Yeah, go ahead and pull up the slide deck since you're screen sharing, and I'll just sort of talk.
Sure. Just a second, let me grab it from.
Oh, everything is okay again. I don't need the other computer. That's nice.
Oh. Okay. Yeah, are you good, or do you still want me to share?
I am all good.
Awesome.
All right, so we are not paused for a break, everybody. This is full steam ahead. Here we go. I love this. I love getting to tag team like this. I feel like it's such a nice combo of different materials. Like Squeeze is what I'm going to be taking away. I've got this nice little tab over here. So, all right, everybody, it's your turn. Maybe that's my way of making everyone else in the presentation work, but that's my style. So we're going to set up some breakout rooms, and each room is going to correspond to teams, and each team is going to get a data set and a story to tell with that data. Using these techniques, it would be great if you could attempt to make 2 visualizations of the data, because didn't I just mention that there's so many options, and to estimate your evaluation criteria, it's often easy to do if you have multiple things to look at. You can say, oh, here's an alternative. It seems to be doing this better than that. I chose different marks, different channels, things like that. And I don't know if I've actually set it up so that we can share these visualizations on Google Drive, but I can work on that as soon as the teams are set up.
Oh, or we can
But-
just have folks, yeah.
Or
Yeah,
their
either way.
screen share and stuff like that.
Yeah.
So in general, please go through and make sure that you're ready to talk about what works well for the visualization, why you made certain choices, colors, marks, and axes. And if you ended up making these two, you know, if you get that far, which one do you prefer and why? So, so now I'm actually going to turn it over to you. This link, bit.ly cctviz, should take you to a folder, if I've done this correctly, where we have a document and then a spreadsheet. And what I'm going to do is recommend that, I suppose in R, yeah, you can download a spreadsheet that has multiple sheets in it and then be able to do viz from each individual sheet. I'm not an R specialist, and so that'll be probably up to everyone else in the call who's a guru to talk through. But let me just briefly go through what's in this document here. So this is sort of the exercise description. So the prompts are what I'm gonna go through now. So I actually have 4 different data sets. I told you they're all super fun. Not at all. No, they're all kind of sad health informatics data sets. So one of them is a measles outbreak data set from like 1 or 2 years ago. Another one is the global burden of disease. And then I think that there's another one that I think is national causes of death data. And then I think the third one is alcohol use in different age categories. So I originally was like, I'm going to put people in each room, but these are intense. And if you have like an association with one of these, you don't want to like be, you know, enmeshed in, please do not pick that. Please pick a different group. So I'm going to let people self-select the breakout rooms that they want to go into. And if we find like one person or one category, one prompt that just doesn't get anybody, that's okay too. But yeah, so if people are able to access this document, when you're going into these rooms, they're broken down by actual stories that I want you to tell with your visualization. So in the measles case, who in terms of age is getting measles in the last 5 years? In the global burden of disease, highlight differences in the number of deaths, you know, according to these different disease categories, and see if you can work in the story about the income category of those deaths. This one is, you know, by state, so show how the 2 leading causes of deaths in a particular state have changed over time. And then under the alcohol deaths, show over time the causes of the alcohol-related deaths. You can focus on chronic causes, acute causes, or both. Right. And I'm now noticing that I did not update. This is recommending that you use a couple of different visualization tools we didn't cover today, so please ignore any of the mentions of raw graphs or Voyager. Just please use ggplot. So, all right.
And I suspect that people will not have enough time to actually get to the point of like plotting this in ggplot, although if groups do, that's awesome. But otherwise, maybe do the hand drawing exercise together, and then maybe think at least about how you might start putting the code together in ggplot.
That's realistic. Thank you for jumping in.
I mean, even myself, like I think it would take me doing it by myself, it would take me a little longer to start actually like downloading the data and reading it in and plotting it. So yeah.
Totally fair. All right. But if people haven't had a chance to get into the drive, let me know if there's something going on with that. Let me check the chat. Yes, thank you for posting that, Renata.
Yeah.
Okay, so do we have breakout rooms already? I think that's the next step.
Waiting to press create. So everyone assort to your preferred breakout room.
Oh, and do they have labels associated with I guess they're sort of by order, right? Like room 1 is measles. Room 2 is global burden of disease. Is that how it works?
Sure if I can label the rooms at this checkpoint.
Yeah, and that's not too terrible. I'll just sort of do a chat here and say room 1 is measles. Room 2 is awesome. I see one person in room 2, so I'm going to join them. See you back here in like 10 or 15 minutes. Is that the deal?
Oh yeah, let's say regroup in 10 minutes.
Okay, cool.
All right, I'm gonna go to room 4. Welcome back.
Howdy, howdy.
Hi, hello. So let's see, how did it go in the... So we have 9 minutes left of everyone's time. Shall we go around and report back?
Yeah, let's start with the measles team. Who talked about measles? And if you're needing me to remind you what questions we were going to go through, I can say them again.
Yeah, it was Carla, Laura, and I. And yeah, Carla was able to actually had the great idea to read in the data into R and then use a squeeze to start making some plots. So
Oh, awesome.
yeah. I don't know if Carly, you want to share your screen real briefly, but
Sure. Yeah, I can do that. It's hopefully still there.
and I think that Laura had a good takeaway, at least from initially looking at the data counts.
So here's the real quick. This is the input data. Oops, did I move everything? Yeah. So this is the input data, the age group, the year, number of cases, and the percentage. And so we read the data with Squeezer. And then the plot we generated was the... Oh, so we put the I'm sorry, I lost it. But we put the years as the x-axis. And then the first was our y-axis. And we generated a line graph. Wait, you guys have to help me out. Oh, the colors was the age.
Ah, perfect. Yeah.
And then I think cases was on the y-axis.
Yes, thank you. And the number of cases. And then it was a line group or a line graph there. There you go. So
got it. Okay.
realize this is not in order. So if you see the legend right here, it doesn't go in order. So that's one thing we noticed. And then we thought that it wasn't like as very clear as to answer to the question, which age group is getting the measles. Then Christina suggested we put a facet here for age group, so it generated different plots. It's again not very, the trends seem to be the same for all age groups. Maybe for 5 to 19 is a little steeper, but yeah, we were working on it. We don't have a definite answer yet.
Oh, this is great. I mean, everyone who's looking at their eyes are probably drawn to that major spike for the 6 to 11. What is that, month-year-olds? No, 6 to 11-year-olds. And I think that, makes a certain amount of sense. Like these are the kids that are in schools, catching it from their classmates and things like that. Thank you. That you got way further than I was expecting in that amount of time. So congrats. I think that means the tools that were presented were really helpful for this exercise.
Definitely.
Good job, measles team. I am going to jump in next because it was...
Just a question. It was this real data?
It is real data. Yeah, this is from the CDC.
Okay, we wanted to know that.
That's why all of these are extra sad. Because they're real. Anyways, so the next one that we were working with was global burden of disease. We didn't get all the way to actually generating anything programmatically. Eric, did you make any sketches? Should I just throw the one?
I got something. I can I'll do what Brian did and put it in the Zoom chat. I know you can do that.
Nice.
So yeah, we talked about doing like a stacked area chart so that the total like area of the thing is the total deaths for a category, and possibly faceting it in by some variables and then having the stacks add up. And like one of the things we talked about is probably what goes is the color category for adding things up versus one of the facets. Kind of just depends on what you want to show with the data. And the other thing that I noticed after making this is that these deaths are not per capita. And so it's actually not that useful to split things out by income category because like I don't know if deaths are if lower in low income category, or there's just fewer people in that category. It's hard to tell.
Yeah. So the other piece of data in there is that this is actually scaled to, I think there's a CDC metric for estimating the categories that are in there. So I think we still see a little bit of that effect, even though you identified a really important thing there. Back to the questions about, different variations that we were thinking about. We had the idea that we could also, instead of showing separate horizontal faceting for male versus female, these could be combined if we weren't actually using solid fills for the categories. And so there would be the ability to compare directly with an individual plot. And then that would allow us, again, if we wanted to collapse things in that sense, we could actually make, horizontal B for these different causes if it was for whatever reason important not to have them in a different plot. So alternations that we could have made. This is so cool. I only got as far as the hand-drawn, sort of set of doodles, so I won't even show those right now. But yeah, I think the third group, we didn't have anybody in the leading causes of death unless there was, unless people switched up which team was team 3 versus team 4. Essentially, I'm saying the last group who has yet to present, feel free to jump in.
Yeah.
Yes, we were discussing a little bit. We didn't go as far as the other groups, but I think we came up with a suggestion of a sketch for how we would present the data. I share in the chat here, I can share the screen as well if you don't mind. So I'm not 100% sure if this is effective. But what we're showing here is in the x-axis we have the years, and we decided to present the deaths per year using box plots. We have two different cause types. The first one was chronic, and the second one was acute. So the box plots would allow us to show how low the deaths were at a specific year, also how high they can go, and we could actually color the dots by the cause type. Here, for example, we have 9 different causes. Half of them were acute, half of them were chronic. So we had 100% alcohol related or other or whatever. So we have 9 total. We can color code our dots here by the cause. And that will tell us about the cause. It will tell us how low the deaths were in a specific year and how high they can go. And also, by having the years on the x-axis, it will show us the trend in time, I think.
Yes.
So I don't know if that's too much data, but potentially we can only do the mean. I don't know what you guys think. I don't know how effective it is. I know I would understand. It probably is the same as reading the table, right? Is that the point? Or we want to summarize a little bit more the data, or yeah.
I think this is great. I think you definitely took to heart the goal of the storytelling exercise and connected it to a prototype of a hand drawing that could be then sort of thought about as how that would be accomplished in ggplot. So, I mean, other people can share their thoughts too, but I'm really enjoying that you took to heart this whole process, starting with this and actually got sort of a strong sense of like maybe what you expect to see in the data.
Yeah, this is step number 1 though. Yeah.
Exactly.
Still move forward. Thank you.
Oh no.
Oh my gosh. I just love like this, joyous color scheme with this really, really intense subject. All right.
Oh my. All right, yeah. Well, we're at 1 p.m. Thank you everyone for being here. Thank you, Devin, for sharing all of your knowledge with us. This has been fantastic. I guess a last link. So Devin shared resources. We also have some resources to share about just like follow up and what our group does before we leave. So there's ggplot2 documentation. All of these links are available on the course website. Oh my goodness, which I'll share later and not subject you to that. Calls for all is we talked about that as far as Esquisse. Our group has virtual drop-in hours on Tuesdays from 9 to 10. You can go join us in Gathertown. We're also available for like short-term collaborations or longer-term collaborations. And next week, we'll be talking more about ggplot2 extensions, of which Esquisse is an example. And there's more information about that and registration here. Yeah, with that, I guess we'll send out a follow-up email with contact information for both of us and anything else to share. And I don't know, Devin, if you have any closing comments, otherwise.
Yeah, no, this was, I think, one of my favorite workshops, providing this material in collaboration with your group. So this was really great. I'm so happy, everybody, that you made it, and I hope the rest of your day goes well.
Yeah.
Thanks.
Wonderful.
Thanks,
Thank you all.
everyone.
Thank you, guys.
Bye.
Yeah, I figured I would just stick around in case there were any last things that you wanted to talk about, in terms of my plan to make it into probably a slide deck